15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello once again, and thank you for joining us on the Space Nuts podcast. My name's Andrew Dunkley, your host, and with me, as always, is astronomer at large, Fred Watson. Hello, Fred.
G'day, Andrew. How you doing, cobber?
Oh, my goodness.
I just can't do it. I can't.
No.
I've only been here for 34 years or something. No, it's more than that. It's 37 years. My God.
One thing Australians can always pick is a fake attempt at an Australian accent.
Absolutely.
Yeah. You've got to be darn good at acting to get away with it, I think.
Yeah, well, I never got it, so...
It's quite natural to those that are native to this land. So we can spot a fake a mile away. Today we've got a lot to talk about, Fred. Saturn's rings are very young, much younger than the planet itself, it seems. Earth's magnetic field, this is a fascinating story, is shifting, and it's shifting fast, and they're going to have to do some adjustments so that we don't sort of get lost with our GPS services. And a question from Trevor Mills about alien signals and the disbursement of radio signals in the universe and what effect that might have. So those stories coming up. But I did want to actually reflect on something I saw this morning, Fred. It was 6:30 a.m. and I was on my way to the radio station. And I just happened to look up at exactly the same moment as I saw a streak of white light cross the sky. Very quickly, it faded in and faded out, and it was seriously the whitest of white light I think I've ever seen. And my immediate thought was to a discussion we had recently, and since I saw it, I've seen a fair bit of social media commentary about Iridium Flares, and it may well have been one.
I think that's almost certainly what you saw, Andrew. Iridium is a family of spacecraft. They're in polar orbits. That means they go north-south when you see them, rather than west to east, which is what most normal spacecraft go when you see them passing through the sky, satellites. So Iridium, they call it a constellation. I think there were originally 66 satellites, and they were for communications. But the reason why they had this curious phenomenon was that each spacecraft has, I think it's got 3 highly reflective antennas on it, which are about the size and shape of a bathroom mirror, kind of pointing downwards, or a wardrobe mirror, a big one, pointing kind of angled downwards. And it was possible to calculate where the spot of sunlight would fall on the Earth's surface that these things were reflecting. And that was done. There are various websites where you can look it up. My favourite is always the Heavens Above website, because it tells you exactly when one of these things is coming. And so as this spot of light passes over you, you see this bright thing in the sky. And sometimes they don't look as though they're moving very quickly. You get the reflection, but it looks as though it's come from something quite stationary in the sky. And you and I have had emails and messages saying, have I seen a supernova, an exploding star? And the answer is no, you've seen an iridium flare. Very, very bright. They can be much, much brighter than the planet Venus, and that's very striking, as you know.
Yes, well, it certainly was very bright, and we had some pretty heavy storms overnight here, and I was lucky enough to have a gap in the clouds, I'm guessing, because it certainly was at altitude. It wasn't a low-level object, so and just happened to look up at that very moment. So it's a great trick. Astronomers love to do this, especially amateur astronomers. They've got a viewing night, with dozens of people around a few telescopes, and somebody's looked up when there's an iridium flare, and then some clever dick will say, if you just look up there, in about 10 seconds, you should see, and sure enough, they see it, because the ephemeris, the calculation of where these things are going to be, is so good. It's a great trick. It makes it look as though you're really in control of the heavens. Sadly, we won't be able to do that for much longer, because the current Iridium spacecraft are gradually being replaced by another
constellation of a different version of Iridium. So this great trick that amateur astronomers can do is going to be a thing of the past.
Yes, well, I didn't have to predict it. I just happened to look in the right place at the right time. So I feel very lucky. Now, let's move on to our first official topic, and that is the Rings of Saturn. Of course, a couple of years ago, they studied Saturn at length with the Cassini space probe before they crashed it into the planet, as we tend to do. But its data is still being crunched, and now it looks like they have discovered or confirmed theories that the rings of Saturn are much, much, much younger than the planet itself.
That's right, and also not likely to last as long as the planet itself either. They're a temporary phenomenon. So this does come, as you have alluded to, this comes from Cassini data. Cassini, the spacecraft that was in orbit around Saturn for 13 years, 2004 to 2017, RIP. It was one of the finest of all NASA, ESA, and the Italian Space Agency was the other one, space missions. It was just brilliant. And we learned so much about Saturn and its rings and its satellites, and about planetary formation generally. So during the final 22 orbits of the Cassini mission, and you and I spoke about this at great length, it passed between the rings and the planet itself. So it actually threaded itself through that gap between the rings and the planet. And that's where these new studies have, or where the data for these new studies have come from. So just before Christmas, there was a paper which I don't think you and I got to talk about, some results that came out that suggested that the rings are actually disappearing relatively rapidly. They're made of ice crystals, and actually up to the size of boulders. And as Cassini went through between the rings and the planet, it detected a flow of ice towards the planet. In other words, it's kind of raining ice from the inner edges of the rings. That was confirmed as well earlier in the year by observations made from one of the Keck telescopes in Hawaii, a ground-based telescope which was looking at the infrared signal of ice flowing down to the planet. This was actually stuff that was flowing along the magnetic field lines of Saturn. So it wasn't going straight onto Saturn's equator like the stuff that Cassini had measured directly. It was heading to middle latitudes, but still a flow of ice particles. And the overall calculation there was that about 10 tons of ice per second are falling from the rings towards the planet, which suggests that they have a limited lifespan. And in fact, people are talking about less than 100 million years for the longevity of the rings. However, but wait, there's more, because there's a new paper hot on the heels of those last ones. This has come out just since the new year, and this is looking at the gravitational measurements that Cassini made during those last orbits, which has allowed the rings of Saturn to be weighed. You can do, by by analysis of the orbit of the spacecraft, you can work out what the gravitational pull is. And it turns out that the rings themselves weigh 15,400 trillion tons. Yeah. There's something like, there's 14 zeros in there.
14-digit number.
Well, it's more than 14 digits. There's 14 zeros and then 154 in front of that, which I think is
it is too.
400 trillion.
See, I can't count that high. That's the problem.
It's comparable with the mass of some of the moons of Saturn. In fact, the piece that the BBC has written on this quotes that as being about 40% of the mass of Mimas, which is one of Saturn's well-known moons, because it looks like the Death Star.
Yeah, it does. It's got that huge dent in it that looks just like the Death Star's weapon.
But if you bring all this stuff together, though, knowing the mass now and knowing the rate of loss of ice to Saturn, you can actually work out how long the rings have been there, and it's no more than 100 million years. Now, that sounds like a very big number. 100 million years is a long time. It's a little bit longer than you or I are going to last, but compared with the age of Saturn, as you said at the beginning, it's nothing. Saturn's 4.6 billion years old. So the rings have been there for less than 100 million years. Some of the pundits suggest not much more than 10 million years. And as we've seen already, they won't last for any more than 100 million years. So we are seeing them at a time when they are quite spectacular, although 100 million years ago, a few tens of millions of years ago, whenever they formed, they would have even been more spectacular because they've been leaking this material onto the planet. So where did they come from? The thinking is perhaps a collision between two icy moons of Saturn. Most of Saturn's moons are very rich in ice, and that's what the rings are made of. So maybe two of them collided and resulted in this pile of debris, which makes the planet the pearl of the solar system.
Oh, nice.
Could be missed.
Okay, so we better take a long last look at them before they disappear completely, although I suspect that won't be a fast disappearance.
Not compared with human timescales, no.
Definitely not. All right. We'll certainly be learning. I guess there's still more to learn from Cassini as well. They're still going through the data.
I think exactly so. I think there will be more stuff that you and I will be reporting on as the year progresses.
Very good. All right. You're listening to Space Nuts. Andrew Dunkley here and Fred Watson there.
3, 2, 1.
Space Nuts.
Now, Fred, we're going to look at something fascinating, but also a little bit disturbing, especially if you are someone who uses GPS to navigate the planet. And let's face it, a lot of us do these days because our phones are all GPS capable. The problem is the Earth's magnetic field is changing, and the North Magnetic Pole is shifting rather dramatically. In fact, it's moved a heck of a long way in the last 100 years, but in more recent years, it's actually moved much faster from what I've learned. This is a really interesting little scenario, isn't it?
Indeed, it is. It is a bit curious. So there's the learned magazine Nature, is one of the principal scientific journals of the world. It had a headline in its January 9th edition, which said, Earth's magnetic field is acting up and geologists don't know why. And that's interesting. And I suppose in some respects it's cause for concern, but I suppose when you think about the magnetic field and the North Magnetic Pole, which naturally moves because there's disturbance within the planet that causes these things, and with modern technology we've become so reliant on systems that are based on these natural phenomena. Exactly, that's right. So the bottom line is, as you said, in the last 100 years, the North Magnetic Pole has moved from being in far northern Canada to being actually quite close to the geographic North Pole. It's moved by 20 degrees of latitude, which is certainly shifting. It is. It's a huge amount. That's in 100 years. And in fact, in the last 15 years, it's moved almost as much in the last 15 years as it moved in the previous 100.
Yeah.
So it's speeding up. It's heading from Canada across the pole to Siberia.
It's a Russian plot.
I'm not going to go there.
They want to control. They want to control the GPS systems. That's what it is.
That could be it. That's right. Just to try and look at the reason for this, it is because the liquid core of the planet is what determines the magnetic field, and that is liquid. So it's kind of moving around. Maybe I can just quote the headline paragraph of that Nature article, which kind of tells it like it is. Something strange is going on at the top of the world. Earth's North Magnetic Pole has been skittering away from Canada and towards Siberia, driven by liquid iron sloshing within the planet's core. And that's the sum total. There is a little bit more to it than that when you read what some of the geomagnetic specialists are talking about. It seems to be that the North Magnetic Pole, its position is governed by two large-scale patches of magnetic field. One is beneath Canada and one is beneath Siberia, and these two are kind of vying for supremacy. And so as one gets slightly stronger than the other, the magnetic field moves a long way. So it is all about sloshing around. But as the lead paragraph of this Nature article continues, the magnetic pole is moving so quickly that it has forced the world's geomagnetism experts into a rare move. And that rare move is about an unexpected update of what is called the World Magnetic Model. The World Magnetic Model is essentially it's a map of the magnetic field all over the world, which is apparently updated every 5 years. The most recent version came out in 2015. The next one should come out in 2020. And why is that important? Because exactly as you've said, this is built into our mobile phones. It underlies the GPS system that
and the cockpits of passenger airliners and the ships at sea, and
yes, and similar things, probably in spacecraft as well.
Yes.
So it came out in 2015, the most recent version, but because the field is moving so rapidly, there is a move afoot to do an interim change rather than bring out a new version of the model in 2020, which is the current plan. I mean, we're nearly at 2020 now, but the experts have brought that forward in order to give us a better fix on the magnetic field for all these navigation questions. There is, however, a slight hitch in all this, if I can put it that way. I'm probably mixing my metaphors, though, and that is that nothing is going to happen because this new model, which is based on a network of something like 160 magnetic observatories, as well as spacecraft in low orbit, there are actually magnetic sensing spacecraft. That new model was supposed to be released on the 15th of January, but it's been delayed because of the US government partial shutdown.
Oh, okay. Yes.
So they can't do anything about it until they've got the effort in place to do that. So it will happen clearly, but it's an interesting story in that it connects the real physics of planets, namely our own, and the fact that there's all this stuff going on under our feet, with our everyday lives as they are now dictated by high-tech implements like these little rectangular boxes we all carry around in our pockets.
Well, if that government shutdown continues, we might have to raid a few museums and brush off a few sextants.
Yeah, sextants and magnetic compasses. I've got a few compasses. I'll be all right. I'm okay. Yeah. No, there's no flies on me.
Just as an interesting aside, the focus is on the North Magnetic Pole. Is anything happening down south?
I checked on this, as I understand it, the South Magnetic Pole is much more stable. Let me just try and see if I can confirm this. I remember reading...
so logic says to me, if one's shifting one way, the other must balance it, but that's not how it works.
Not necessarily, no. There are two different things here at play, Andrew, which I was not aware of, I have to say, before this work came out. And what we're seeing is the movement of what's called the magnetic North Pole. And that's defined by the place where a compass needle would stand vertically if you let it move around in the magnetic field. But there is something else called the geomagnetic North Pole. And that is what you get if you model the whole Earth as a bar magnet and say, all right, take the intricacies of the Earth's magnetic field, take an average thing that makes it look just as though you've got a bar magnet inside the Earth. Where is the North Pole of that? And it's actually in a slightly different position.
So you're telling me there are three North Poles?
There's three North Poles, that's right. The geographic one, the magnetic pole, and the geomagnetic pole.
Good grief.
Yeah, and there are likewise three South Poles. I think the South Pole is behaving more, actually rather more sensibly, and it's presumably...
it's in the southern hemisphere for it.
Of course, absolutely correct. It's more about the fact that we don't have a big magnetic anomaly stuck under Canada and another one under Siberia that are fighting it out at the moment.
Yeah, well, west versus east. There you go again.
That's right. It's there's all kinds of all kinds of analogues in that.
Yes. Oh, well, it'll be interesting to see. And is this perhaps got anything to do with the predicted reversing of the polarity of the Earth's magnetic field?
I guess in the long term it has, because we know that's happened many times in the Earth's history, that the magnetic field has flipped. And the Earth's magnetic field is certainly getting weaker at the moment. And you can check that, magnetists look at things like the hematite in Roman clay pots and how that was orientated, and they can work out the magnetic field from that and know that it's actually declined. And in fact, in the last 200 years, we've had sensitive records from sensitive magnetometers. So we know it's declining. I do remember writing a long time ago, when I was writing about this for an encyclopedia, that the way it's going at the moment, in about 1500 years, it will get to zero. But whether that will happen and whether it will cause a magnetic reversal, these are things that nobody can predict, because apparently the magnetic field of the Earth is one of these things that does exactly what it likes. It doesn't really behave according to any models at all.
Yeah, very cyclonic, very much like a hurricane. You can't predict
weather.
them.
Exactly, it's like weather.
Okay, we watch with interest. One other point, I read an article a few years ago now, but talking about the real North Pole. They have to move that too, because the ice shifts. So every year they have to go out and go, okay, it's not supposed to be there now, and they have to shift, because there is actually a pole where the North Pole is, and they move it according to the shifting of the ice. That's what I'm told, anyway.
Oh, they would on the ice, that's right. But the North Pole does move around, but only over a matter of meters rather than...
Yeah, exactly. But every year, I think it's on New Year's Day, in fact, they go and put it where it should be, because it's moved. Yeah, it's all very fascinating. Well, this one's been really interesting, so we'll keep an eye on that one. But if you're flying overseas in the near future, just bear that in mind.
Good luck.
This is Space Nuts, Andrew Dunkley and Fred Watson.
Roger, you're loud and clear here also.
Space Nuts.
Finally, Fred, we get to an audience question, and we say hello to Trevor Mills, who has a question for us about, radio signals in space, basically. He says, "Hi guys, just wondering how practical it is for us to detect radio signals from aliens, or for aliens to hear our radio signals. Our civilization has been leaking radio signals into space for about 100 years, probably more. But could they have really travelled 100 light years and still be detectable, given the inverse square law would make the signals so weak? I expect they would be almost impossible to detect at that distance. So my question is, how far could our normal radio and television transmissions realistically travel before they would become too weak, making it difficult for another civilization to detect them?" That is a great question, and Jodie Foster knows the answer. Because if you've seen the movie Contact, then that was all based on a radio signal that was received on Earth from the star system of Vega, which is a long, 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 long way away. But not that far, I don't think.
Actually, this question...
It's 25 light years or something.
Yes, it's something like that. That's right. I'd need to check that too. But this question, I do remember, was answered by a friend of mine, in fact, who is a professor at the University of Arizona in America. In fact, it's based in Tucson, Arizona. And he did the calculation, and I can't remember the answer he got, but it was something in the region of 50 light years. That, a signal that we would make could be detected. So the Earth is radio bright. In the radio spectrum, the Earth is relatively bright because of all the transmissions throughout the world. So exactly as Trevor says, it's been leaking radio signals into space. The ones 100 years ago were probably a lot weaker than the ones in 2019, but we still do have a very high level of interference into space. And so I think Chris Impey, the friend of mine, Professor Chris Impey, I think his calculation was in the region of 50 light years before it becomes impossible for anybody, because the signal is so weak that you've got quantum noise effects that are playing havoc with what you're trying to measure.
Okay.
However, if you think about very, very sensitive radio instruments, and add in not just the broadcast signals, but things like radar and things of that sort, throw all that stuff in, then that 50 light years is probably about right, because I've certainly read that the square kilometre array, which will be the most sensitive telescope in the world when it's built in the 2020s, and it's a radio telescope. It's clustered around two centres, one in southern Africa, one in Western Australia. And both those countries have got sort of precursor versions of their instruments, which are working very well. But when it's finished, part of the blurb says that it will be capable of detecting an airport radar, not just a planet full of airport radars, but an airport radar. And I think the figure, I'd have to check this, but I think, again, it's about 50 light years.
It really narrows the potential, though, doesn't it? Very, very significantly.
Yes, that's right. It does. But it does mean that we are not, that Trevor's on the money, that if there are intelligent aliens within 50 light years of the solar system, they could know that we're here. They could.
And now that we're getting better and better at discovering exoplanets and exosolar systems, and more specifically Earth-like planets, then we may well be able to target potential planets within that that's right, time frame or distance frame. The other question that comes into play, I suppose, is if we were to detect a potential planet, would we be able to focus a signal, say via laser or something, so that they got a concentrated burst like the WOW signal, for example?
So are you talking now about us sending out
Yes.
signals to? So that's something that we've only done on a number of occasions. There have been, when the Arecibo dish was opened. This is a 300-meter diameter radio telescope in Puerto Rico. When that was dedicated, there was a burst of radio signals sent off towards a star cluster with a pattern basically built into it. But that's virtually the only directed signal to aimed at an alien species that we've ever sent. And the reason for that is it's ethically rather an interesting question whether you want to beam stuff up. And in fact, one of the facets or arms or wings of the Breakthrough project is looking at the ethics of exactly this. So that Breakthrough project has three parts to it. One is Breakthrough Listen, which is currently in action. We're listening for signals from two of the world's great radio telescopes as to whether any alien messages might be found among them. Breakthrough Listen, then Breakthrough Starshot, which is the idea of propelling spacecraft to Alpha Centauri on a laser beam. And the other one, whose name I can't remember, it's Breakthrough something else. That is actually looking at the ethics of sending a signal out there and what it should be if we should do that. And there are certainly people, I mean, the late Stephen Hawking was dead against that kind of thing because he said, we're opening ourselves up to all kind of possibilities.
But the question, you can look at it from several perspectives. But if we are sitting here listening, then we are wanting aliens to send a signal to us. So why not do the same back? That's the other argument.
Yeah. And then it's all about the history of species interacting with one another has not been good usually for one half of the species.
Violence tends to ensue.
Yes, that's right.
Yes.
Yeah.
And that is certainly, well, I was going to say a risk, but no, a factor that you should probably consider.
Take into account, that's right. So that was certainly at the back of Stephen Hawking's mind. Wasn't it?
I suppose one other point I guess that's popped into my mind as a result of this, we talked, well, have talked several times and will be talking again soon about the remnants of the Big Bang and how it, even though it only lasted 380,000 years, we can still see the effects and detect the photon signals. So why wouldn't radio signals we create still be detectable under those circumstances?
Well, they'd have to be as bright as the Big Bang.
I see.
So the Big Bang was the...
We've made a few Big Bangs in history.
Yeah, well, that's right. We have some of which are more memorable than others. Some are positively embarrassing, actually. But the Big Bang, yes, it was such a cataclysmic event that its effects still reverberate through the universe in the form of the cosmic microwave background radiation.
Indeed. All right, Trevor, thank you so much for what was a fascinating question. It's, and now you know that we've got a 50. Well, it's the 50-mile limit, basically. Once we get outside 50 light years, all bets are off. Thank you, Fred, as always. We appreciate what you do and how you do it, and it's great fun, and we'll talk to you again next week.
Sounds great, Andrew. I look forward to it. Take care and have a good week.
That's Fred Watson, astronomer at large, and from me, Andrew Dunkley, thank you as always for listening to Space Nuts. Don't forget to tell your friends and keep in touch, and we'll talk to you next time.
Space Nuts. You've been listening to the Space Nuts podcast. Subscribe to the full podcast on iTunes, Audio Boom, and Stitcher, or your favourite podcast distributor. This has been another quality podcast production from Bytes.com.